Hi, this is Jiaming, and today I'll be teaching you about permutations, which is a form of combinatorics when order matters. Okay. First, let's go through the definition. A permutation is the number of ways a set of objects can be ordered or arranged. To see this more clearly, we will look at an example. So suppose you have 10 people running for the student office and 3 different positions. How many different possible set of officers can you have? So now let's suppose we just have 3 people who have been selected, and we have Amy, Bob, and John. It really does matter a lot if Amy's president, Bob is secretary, or John is treasurer. And any other combination of this, for example, TSP and etc., that'll be a completely different office. Therefore, in this situation, we can see the order of how you pick the way you pick president, secretary, or treasurer really does matter, and that's what it means by permutation. Okay, so in other words, permutation is an ordered combination. Today, we'll look at 2 different types of permutations. One is when repetition is allowed, and the second when repetition is not allowed. For example, when repetition is allowed is when you have n things to choose from, and there are n choices each time. So the number of choices do not decrease as you choose. For example, we have a permutation log. Each of the numbers go from 0 to 9, as we can see here, like each of them go from 0 to 9. And something like 0, 0, 0, 1, 1, 1, 2, 2, 2, 3, 3, 1, with repeated digits, that's allowed because we can have those combinations on our log. So therefore we ask ourselves, how many different permutations are there for the log? Well, this might sound a little intimidating with the big word permutation. Let's rephrase the question to something more understandable. How many choices do you have for each of the log numbers? We can simply see how many choices we have and then multiply them together. Okay, so let's look again. We have the first position here. How many choices do we have? Okay, we have 0 to 9. That's 10 choices. For the second position here, we again have 0 to 9. That's another 10. And similarly for the last one. So in total, for a permutation log, we have 1,000 different combinations possible. This is why it is quite hard for someone to crack a permutation log without any previous knowledge, because you have to try 1,000 different combinations to actually get the password right. So now let's look at the second case, when no repetitions are allowed. So therefore, you reduce the available choices each time. For example, if you start with n people or n numbers, anything, you will go to n-1, n-2, or something like that. So once you choose something, you cannot choose it again. So let's look at our previous example of choosing officers, right? We do not allow a person to be the same position twice. Therefore, it is a no repetition allowed choice. Okay, so again, you have 10 people running for the student office and 3 different positions. How many possible sets of officers do you have? So again, let's look. We have these 3 positions. Let's say this is president, this is treasurer, this is secretary. We will see later that this doesn't really matter what order we choose them in. So first, how many people are there available when we choose president? Assuming all people are qualifying, we have 10 people at first, right? And after we choose the president, now we have 1 less person. So now we have 9 people for our second position of treasurer. And then if we go on to the secretary, we see that we only have 8 people now, similarly. So therefore, there's 10 times 9 times 8 different possible set of officers that you can have. And again, we see that these, if we simply switch the subscripts here, SPT, when you pick secretary first, there will still be 10 people at first. And then when you pick president, there will still be 9. So what we're choosing, the order we're choosing does not matter. It just really matters for these 3 positions. We have 10 people at first, and then 9 people, and then 8 people. Okay? So this is a very brief introduction into permutations, and we will see more elaborate examples in our next class. Thank you for listening.